Greetings! In a recent video, we adopted a distressed Radio Shack TRS-80 Model 3 computer, which was showing signs of life but wasn't working properly, and we started to diagnose it, fixed a few minor things, and the main diagnosis showed us that one of its two power supplies, identical power supplies like this one, had failed. And this was the one that was powering the logic board and the monitor. And then there was another one that was powering the dual floppy drives and the floppy controller. So the one that powered the logic board, which was this, had failed. So I started to diagnose it, found some bad parts, replaced them, created more bad parts and smoke, replaced them, checked a bunch of stuff. The farthest I got at that point was that under no load conditions it would output the proper voltages, but the minute you hooked up something to it, it would kind of try to go into constant current mode and supply stuff with the voltage falling rapidly, and then it would blow a fuse, which was over here. After being sick and tired of having to keep soldering pigtail fuses in, I just added this fuse holder, but that didn't change my luck. So taking a valid engineering approach is that, hey, you should only spend so much time on something if you can replace it relatively easily and inexpensively. So I dug through my drawers of parts and I found another power supply. This guy. So that reflects nicely. That's better. Let's prop it up so it's not that shiny. So basically what I found was this power supply here. The base, the plastic base, and the proper output connectors were added by me. It just had a plain 6-pin 0.156 header here, and I just ran that into the connectors required. And since the power supply was functional, I put it in, I hooked up everything, and the computer started to work. Now it did show some weirdness, which I found out was that the original power supply, when powered up, almost immediately generates the output voltages. This one had about a 2-second delay. The machine expects all the power to come online at once, and because of the non-syncing of the disk part and the logic circuitry, it was acting a little bit strange, but it was working. Basically what it boiled down to is I would turn on the machine, it would not see the disks, then I would just reset the machine and everything would be fine. So yeah, I even tried swapping the two power supplies between logic and floppy. I put the slower one on the logic side and the faster one on the floppy side, and that's when things really started acting weird, so I swapped them back again and the machine became usable, with the only hang-up being when you hit the power switch it didn't check the floppies, and all you had to do was hit the reset button, which is on the keyboard assembly, so it wasn't a big deal. Life went on, but this bugged me to no end. This is not the world's most complicated circuit. There are no exotic chips or anything mysterious on here. Everything on here is pretty much off-the-shelf parts. So why couldn't I get this? Why couldn't I fix this? We left it at the point where without a load connection, without a connection to any of the outputs, it will come up with the proper voltages. But once I put even I only connected the floppy controller card to it, and it acted the same way. It started up, the voltage dropped from 5 volts to 3.1 volts, and then the fuse blew. So let's go over what I did to get to that point and what I did thereafter. So first and foremost, it only had one refa across the AC input over here, right after the fuse. And I don't know if that shows up at all, but crack was beginning to form right in the middle of that case. So this one would have blown up very soon. But I did that before doing anything else, and that should be considered standard procedure by now. I then checked around and visually determined that this transistor, which was the pre-driver for the primary oscillator, which you can't see, had blown not its top but its side. Okay, so that guy is bad. I found a replacement for it. The transistor is in here. So what this does, this transistor with associated components drives the master, the power transistor, which supplies the sine wave or the AC to the flyback or to the main transformer. That outputs it on its secondary side, chops it through these converts it to DC through these large diodes, and outputs voltage. And of course it has a feedback loop that informs the primary what the output voltage is, and the oscillator adjusts the input AC through this, and everybody's happy and we get a beautiful output voltage. Well, I did that, and the master transistor over here started to smoke. This guy. So obviously the reason this transistor had blown was some of the support circuitry is bad, and it was just probably stuck open, saturated the whole time, feeding full blast into the power transistor, which tried its best to supply a large amount of voltage to the transformer and then couldn't handle it anymore and blew up. However, this time I wasn't going to be sloppy, and I checked more stuff. And what I found, and I don't know if these were blown before or not, before I replaced this transistor or not, but I suspect some of them were. There was an open resistor which looked just fine. Well, there was a little bit of, it's really hard to see, but it really didn't show anything bad. It didn't look like it was visually damaged, but it was open. Of course, I didn't have a replacement that same value, so I made one up of two different ones and tented it over here. So that fixed that. Then I found an inductor over here that's in the feedback circuit for the power transistor. No, actually for the pre-transistor here in the oscillator, that was open. So that took me a few days to get a replacement, and I put that in here. And let me look at my inventory of replaced parts, and then I measured around, and this electrolytic, which is also sitting in the primary oscillator side, had drifted way out of spec. So I replaced that one too. Well, everything seemed to be hunky-dory, so it came time to turn it on. Well, I turned it on, checked the voltages. As mentioned before, they were fine. And then they disappeared. And I tracked that down to the original fuse. It's not actually a fuse, it's actually a fusible resistor. And a fusible resistor is basically built so it blows at a certain amount of power. There's no fuse in it. The resistor itself is made so that if a certain amount of power is exceeded, it opens up. The advantage of a fusible resistor as compared to just a fuse is that when you turn on any device with a linear power supply, there usually is a great current inrush when you first turn it on. And the reason for that is that when you turn this thing on with everything discharged, the main filter cap over here basically shows up as a short circuit because it tries to charge as fast as possible. Now, if you just have a fuse in there, the inrush current itself may be too much while this is charging and blow the actual fuse. So the added advantage of a fusible resistor is not that only that it acts as a fuse, but it's also a resistor, so it limits the inrush current. However, yeah, I couldn't find one of these in short order, so that's when I put the fuse holder on here, and I put a 1 amp fuse in there because that's what it's supposed to deliver, and I figured, well, if the fuse blows, I'm probably going to have to go to like 1 1/4 amps or something because of the inrush. And I turned it on, voltages were okay. As I said, I hooked it up. And what happened this time, here's a 3-inductor combo, whatever you call this component, and it started smoking right here, this black spot. And this is in the voltage feedback circuit that controls the primary side based on what the secondary side is seeing on the 5-volt output. So I said, yeah, oh great, I blew this part. And even though tens if not hundreds of thousands of these were made, even for a Radio Shack, I'm never going to find one of these. So, you know, I mean, the only way I'll find one of these is if I find another power supply. And if I find another power supply, then... Anyway, you see my point. This part can't be obtained reasonably. And so at that point I decided to drop it and build this monstrosity, which made it work, but didn't really satisfy me. And I forgot there was another power resistor where I guess I didn't keep the old one, but this guy here standing way off, this was also open, and that's again in the primary oscillator side. That was done along with all of these guys down here, but that didn't fix it either. Long story short, last night I had a bunch of things to do. I neglected to do any of them and said, come on, you know, you don't have my butt kicked. I'm going to keep checking here. And I checked everything. If we have a look at the schematics, if I can find them. which I think I showed last time too. But yeah, I went back and checked all the components again. Everything. Everything that looked weird came out. I must have spent 2 hours on it. For a while I started to suspect the crowbar protection circuit here, which basically has an SCR that can short 5 volts to ground, and it uses a Zener. I couldn't find any numbers on the Zener, but it's probably like a 5.9 volt Zener or something. And if the voltage on the 5 volt line exceeds the Zener voltage, it'll turn on the SCR and just pretty much blow the output. I mean, this is going to, when you short the 5 volts to ground, it's going to blow the fuse. But anyway, I took that out, ran my experiment again, and it blew the fuse again. So it was not the crowbar doing it. So now I was getting slightly discomforted by this situation and started yet again measuring everything. And I couldn't really find anything. I had pulled all of the capacitors, the electrolytic ones, and you know, they were a little bit off. The value was a little bit off on them, but they were all close, and their ESRs were low enough, normal. Since nothing in here showed up, even the transformer or that multi-inductor assembly thing that had the black burn spot or melt spot on here. I mean, I measured those. They showed a few ohms, which is, you know, that's an inductor in an application like this is not the most complicated. It's not in its most complicated operating mode. If it shows a few ohms, then all the windings are there and they're connected to the terminals. Sure, it gets more complicated than that, but not in this application. So I looked at the. So I kind of looked at it. What was happening? The device was coming up in constant current mode and then blowing a fuse. I checked everything. Really, I promise. I even checked all the other inductors, like here, the massive diodes in here. I didn't even have to take these out of circuit. They all measured properly in circuit. Transformer loops, transformer windings, in here, everything was okay. So if something shows an extreme voltage droop, if all of the complicated theories don't work, what does that point to? Well, it points to smoothing capacitors. Well, I had them all checked, and they were okay, so there wasn't anything else I could do other than replace them all. And you know what? It started to work. So here you go. I replaced all of them. And I guess what I did, which is borrowing a term from the auto repair industry, is I threw the parts cannon at it. But it fixed it. I was still curious. I couldn't see anything on here. None of them visually leaked, was dented, bubbled, bulged, whatever. I measured them again. They were fine. But you know, my measuring, I don't have a real good LCR meter. I just have a real crappy LCR meter, this guy. And basically this is a go, no-go thing, I guess. It tells you what the approximate value capacitance is and what the ESR is. And sometimes it even has an efficiency number appearing. But I guess the stress that this puts on the capacitors is not even come close to by the 4 volts that this outputs. So, buyer beware. this thing can fool you pretty badly. But here it is, and I was able to attach loads to this. There was a slight voltage drop on the 5-volt line and everything, but nothing weird, no sizzling, no crackling, no smoke, no nothing. I'm going to keep this on here until I find a fusible resistor. It's a 2-watt, 2-ohm fusible resistor. I just have to be patient because they come from China and it takes like 3 weeks. But I shall do that. And now, let's put this back into the machine and see if things still work. Or start to work with this power supply. Alright, I took out the power supply I built and put in the freshly repaired one in place, plugged it in, and now that I look at it, I forgot to plug the AC supply into it. Where are you? Oh, here. Click. Alright, we got AC hooked up to it. We got both disk drives and the floppy controller hooked up to it. We have a DOS disk in the drive. So let's turn on power and see what happens. Ha! It did boot TRS-DOS. So now it wants it to stupid hello. One 180. And it seems to work. So one thing I'm going to do is I'm not going to put this thing together yet. It's getting kind of late tonight, but what I'll probably do is tomorrow, every time I walk past this computer, I'm going to power cycle it. See if the fuse blows again, see if the floppy disk becomes erratic. But I think it's fixed. Thanks for watching. Please subscribe, hit the bell, comment and like, and we'll see you next time. Well, I had to add this epilogue. I didn't want to post before actually testing this, so I've power cycled the machine a few dozen times, and it's still working great. I'm going to keep these caps around till I acquire a real LCR meter, and at that point I'm going to measure these, because I'm really curious which one the culprit is.